So I'm gonna switch tracks to something and be a little bit self-indulgent.
Yeah,
and,
sure.
And pick on two areas that frankly inspire me and frighten the crap out of me.
Sure.
Okay, one is black holes. they I know we're not near one. Well, in any like reasonable
They are scary.
sense.
They're really scary.
But the concept of this thing just
Yeah.
just frightens the crap out of me. The second thing is this entire concept of like the cosmological horizon and what's beyond that. I know there's stuff beyond it, but it starts raising all these philosophical questions about the nature of if you can't see it, does it still exist? Well, you can postulate. So, dealer's choice. What do you want to tackle first and frighten me with?
You want
So-
I won't frighten you with either. You want to start small quotation marks with black holes,
You're-
and then
you're the
and then
prof.
go up,
Take
and
me
then
through
go
it.
big to the cosmological
I'm
horizon.
your student.
Yeah. Well, so black holes are awesome. You probably saw this. I mean, hopefully a lot of your listeners as well saw this press release of this image that was taken of a black hole, which, all of us. I mean, I remember I was watching the press release and I almost fell out of my chair. It's absolutely stunning that we can do this, and this is not the place to do this. But remember, these people built a telescope the size of the planet in order to do this, which is kind of, I don't know, it's amazing on how many levels, not from just a technical standpoint, but to get people from like 20 odd countries to all, work together and, use their telescopes from, Antarctica to Australia to, Europe to South America to North America. It's an amazing endeavor in human cooperation as well. So it's a really beautiful thing. But I wouldn't worry about black holes too much if I were you. So there is a black hole in the center of our galaxy, but it's really, really far away. It is about 25 to 30,000 light years
So
away
if I
from us.
traveled at the speed of light, it would take
Yes.
me 25 to 30,000 years.
That's right.
To get there.
And if you think about how long it's taken for like Homo sapiens to like evolve, it's something like 100,000 years. So, if you had left around the time that man was starting to develop agriculture and just pull himself out of hunter-gatherer societies, you'd only be getting there now. If you were traveling at the speed of light, it's really far away. So it's not gonna harm you. And I think the other thing people need to know is that black holes don't suck anything in. They don't suck.
So explain that. Why do they not? Because everyone's got this in sci-fi. They've got
Yeah.
this notion of you're gonna get sucked in this thing and then you get destroyed and then
Yeah.
I've heard this spaghettification and all this stuff. Like they toss these like words around, but lay it down. Like what's the actual truth about these things in terms of like do they suck stuff in? Is it just if you get too close, okay, then it's like the point of no return? What's that all about?
I think you said it. You're a wise man. Yes, if you got way too close, you would get sucked in. But for example, a great example is if I took our sun, right, and I made it into a black hole. I just gave it was the same mass, but I made it into a black hole. What would happen to the Earth's orbit? Any guess?
You're saying okay, so the same mass, and I'm gonna guess
so-
here. So
yeah.
if it's the same mass,
Yep, same mass. I take our nice big fluffy sun and I crush it down into a black hole that's just like the size
so
of a
nothing
pinprick.
would happen to our orbit. Is
Nothing
that
would
correct?
happen to the
Okay.
Earth. That's right. We just keep going around in a circle, right? Nothing at all would change because that's how orbital mechanics work. So the only time you ever have to worry is if you got really, really close to a black hole. And I'm talking even closer than the Earth is to the sun, right? And the Earth to the sun is about 8 light minutes. So 8 minutes at the speed of light, you would hit the sun. Remember, I'm saying that the Milky Way black hole is 25 to 30,000
Okay.
light years. So even if you're only 8 light minutes away, you still wouldn't fall in. So you don't have to worry about that.
So what happens? I mean, like you get close, and this entire concept of this event horizon.
Oh, yes.
We can't see anything beyond it, and why is that? Why can't we see anything beyond it? And what does that tell us about the nature of like existence? Like stuff falls in, it doesn't come out, and we learn about thermodynamics, and okay, what isn't that stuff falling out of our universe? Then isn't that kind of this principle being violated over here? Am I kind of asking the wrong question?
No, you're asking the right questions. There's like 5 of them in there, and they're hard ones. I mean, we don't know a lot about what's going on inside a black hole. The idea is, so we think black holes have like an edge, and this is this thing you mentioned called the event horizon, which is this edge is where even if you were inside the black hole and you set off at the speed of light, you could not get out, right? Light cannot escape from a black hole.
So I'm inside. I fall inside the event horizon.
Yes, you can't get out. Even if you traveled at the speed of light, you could not get out. And
so how fast would I have to go to be able to get out if I fall in?
well, faster than light, which we don't think is possible. So you're never getting out in principle. But that's a whole other thing to get back to. But so the event horizon is kind of the size of the black hole at which, if you were just outside the event horizon, if you traveled at the speed of light, you could eventually get away from the black hole, but it would take you, millions of years. Once you cross over the event horizon, you're never getting out again. So it's kind of a place where, and we won't go into relativity, but because you're going to be traveling close to the speed of light, time stands still. And so that's why it's called the event horizon. Events no longer occur at the surface of a black hole because time is sort of effectively standing still, which is a weird concept.
So does this entire concept of, redshifting also apply to a black hole then?
Absolutely, yeah. Well, did you study astrophysics?
No, I mean, I'm taking from what you've kind of told me, right? Because it's like stuff gets stretched.
Absolutely.
I'm only just presuming.
So in fact, that's what it looks like actually, is when something falls into a black hole, if you were to watch it fall into a black hole, it would kind of get smaller and smaller. And then just before it hits the event horizon, what you said would happen is it would get massively redshifted because the light is trying to get out of the black hole. And it is, but in the process, it's being massively stretched out by the gravitational field. And so things actually turn super red and then disappear as they fall into the event horizon.
So would I ever see, like, if, some guy on a rocket is going near a black hole, would I actually see him or her falling in?
What would it look like if they went in?
Yeah.
What would you see? So you would see them getting smaller and smaller as they got closer and closer, and they eventually would start to turn redder and redder and redder and redder, and then one day you wouldn't see them.
Because I just can't perceive that, like, it's
well, even if you could, eventually once they cross the event horizon, they kind of vanish.
And so what, in your understanding and view, like, what is the inside of these things? I mean, people talk about, is there a different universe, different reality? I know Neil deGrasse Tyson, like, he's, I love the way he articulates things, but, I want to find out more. Like, is there a theory? Does it become philosophical at that point, or is it more scientific?
Well, so we have no theory. So what we need in order to understand a black hole is what they call quantum gravity, which we don't have. And the idea is, and your listeners who may be somewhat fans of science, the law of gravity, as we know it now, is sort of Einstein's theory of general relativity, and that explains how gravity works on very large scales. On very small scales, we know that the way things work is with the laws of quantum mechanics. However, if you think about it, the very central part of a black hole is very powerful gravity on a very small scale. So you need something that, obeys the laws of general relativity, but also obeys the laws of quantum mechanics. You need a quantum theory of gravity, and we absolutely do not have it. And we've known we've needed this for a very long time, and it's just, we haven't had a way of really understanding how to make that kind of stuff work together. And so we can't really explain what's going on inside a black hole. People work on these things, but it's just incredibly difficult. Now, some of these observations we're taking, like you saw this image of a black hole, they help a little bit. They confirm that even on the size scale of a black hole, they look like what general relativity predicts. And we didn't know that, right? So general relativity holds right up to the event horizon of a black hole. We learned that this year, which is really, really exciting. But we still, if you want to know what's going on inside the black hole, I have nothing. People have theories, of course, but I have no way of really knowing of any of it.
I guess that's where my question kind of came in at that point. Does it really become more of a philosophical or creative matter where people are going to come up with a guess as to something and then say, let's go out and try and find the data? But from what you're saying, like, nothing really comes out of there, so you can't really prove your hypothesis. I guess you have to have a way of observing what kind of happened, right? Or like inside
absolutely.
it. But how do you get that?
But also, like, I don't know how to, you've taken a degree in math, so you understand that there are just ways of writing down math that don't speak to each other, if you know what I'm saying. And general relativity and quantum mechanics are like that. They just don't know how to speak to each other. They're like in two completely different languages. And so you would think, this happens in physics when we realize that, in fact, general relativity was taking Newton's laws, all these things like, how balls fall off roofs and stuff that Newton was working on, and putting it in a much larger context and realizing that all the things Newton wrote down were just a small part of Einstein's theory of general relativity, that they're just a special case of this greater understanding. And what it must be is that quantum mechanics and general relativity on their own, while incredibly all-encompassing theories, must be special cases of some much larger theory of everything, right? Which you may have heard of. There was a movie, this is the kind of thing that Stephen Hawking
the theory
was
of everything,
yeah,
right?
Stephen Hawking was very excited about this. They made a movie. The movie of his life was called Theory of Everything. And so this is what people want, to try to make these other theories, special cases of this larger theory of everything. But we really don't know how to do that at the moment. And it's, it could be a very, very long way off. Although I don't want to discourage people from trying to solve it, because it would make my life a lot better if someone could come up with a theory of everything. But it's hard. We're waiting for the next Einstein.
Do you think we're going to see this type of theory like within our lifetimes, or do you think it's, we need to evolve as a species to some other, not only just in terms of our own mechanization, or maybe rely on AI to be able to come up with these types of theories, or figuring out how to peer into the nature of higher dimensions that we ourselves can't even perceive at this point?
These are fantastic questions. I love these questions, and I don't know. I mean, it's so hard to say, when does scientific discovery happen? Particularly, when does absolutely groundbreaking scientific discovery happen? No one knew that Darwin, sailing on this boat to the Galapagos Islands was going to revolutionize biology, right? He was just some guy going on a boat trip and then went, I got an idea. And so I have no idea. It could be a long way off. On the other hand, you said something that's really exciting to me, which is AI, right? I mean, I think we are, those of us in science see the AI, everybody sees the AI revolution coming. Those of us in science see the AI revolution coming, but we have no idea how to use this thing.
Well, tell me, because I live in a world where there's so much hype about AI, and I'm giving a talk in a couple of months about this, but what is your view on AI? I mean, as far as not only your field is concerned, but how you see it kind of in society. I'm very fascinated because you've got a very different lens than what I kind of bring into it, right? So what does AI mean to you as a professional, as a citizen, right? So.
Before I get on a soapbox, it's a natural progression. I think it's super scary to everybody, but this is happening, right? This is happening, and so does it make your life better? I don't know, but it's going to happen, and so I think now is the time to embrace it. You can imagine a future where it does all sorts of useful things in society, and so then to take the lens to my own field, I mean, you're talking, we were just talking about probably the hardest problem in physics, right? The theory of everything. There is no more difficult problem in physics, and we have made limited progress on that for a long time, and it might be that AI is capable of that. Wouldn't that be really exciting? And then you would say, wow, there's something that AI achieved that humans, who knows, after 1,000 years we may have achieved it. But AI might have sped up the process by a factor of 20, that it got done in 50 years instead of 1,000. And so that would be really exciting, right? I think the thing is that people are bringing AI into scientific research. I'm talking from the astronomy perspective, in very limited ways, kind of step by step bringing this in. In my own field, people use it to classify galaxies. Galaxies are like people, they all have different faces and heights and hair colors, and they're all kind of the same thing. They're all galaxies, just like people are all people, but in detail they're quite different. And so AI is very powerful at spotting trends, and so people are bringing it in to kind of do these smaller tasks. But you can imagine a future where, as you said, it actually not does it just do a little bit of cataloging for you, it solves problems, right? And that would be really exciting.